All right, and we're back with day 5. Let's estimate those roots and compare some numbers. So our essential question is, how can I estimate numbers written in different forms? So really, if they're in different forms, I just gotta get them to the same form. But first, if you've been keeping up with me, I want to do a quick review on negative exponents. Um, let's write each of these expressions using a positive exponent. Go ahead and pause the video and check to see if you get the same answers. And we're back. Yep. If you pause that video and want to check your answers, these are those answers. Very straightforward and clear. The only one here to look at really is f. I'm moving the m to the negative third power into the denominator to make that exponent positive. The y has no exponent, so it just stays put. Awesome. Let's keep going. Pause the video again and see if you can get g through j. And we're back. If you got these answers, then you are correct. A lot of people were somewhat confused before with one of my previous examples of negative exponents with the negative 2 to the negative fifth power. That negative 2 is the base. It retains its negative sign while the exponent becomes positive because that's what we are writing each expression as a positive exponent. Cool. So let's dive into estimating roots. Okay, so the question is to estimate each root to the nearest integer. I wrote a number line real quick and dirty, just a horizontal line with some numbers on either end. Now the real question is, why is it between 10 and 11? Well, it's between 10 and 11 because I know that 10 times 10 is 100, and the square root of 100 is 10. So that's why I've had 10 right here. Awesome. The same logic leads us to, why do I have 11? Because see, 11 times 11 is 121, and the square root of 121 is 11. So 10 and 11. 110 is a number that falls between 100 and 121. So the square root of 110 is between the square root of 100 and the square root of 121. And I put it right in the middle because it's kind of in the middle. 121 is a little bit closer to 11, but it's pretty much in the middle of 10 and 11. Awesome. So let's take a look at some other examples. We're going to estimate all of these roots. I'm going to walk us through L first. Okay, so 35. If I think about roots or squared numbers, 35 is between 5, because 5 times 5 is 25. It's smaller than 35. And 6, because 6 times 6 is 36. And 35 is really close to 36, which is 6 squared. So that means the square root of 35 has to be kind of like right about there. Kaboom. All right, let's take a look at n, and then if you would like, you can pause the video at any time just to see if you can kind of do these on your own. But I'm going to explain each of these because this is a very interesting concept. So 44.8. I'm throwing decimals at you, but it's not that difficult. Let's see, 6 times 6 is 36. That's definitely less than 44. So that's down here. 7 times 7 is 49, so it's got to be up here. And I know that 44 is definitely closer to 49, so I'll put it kind of like closer to 7. It's not quite 49, but it's right there. See, 35 was really close to 36, so I kind of put it really close to 6. Mr. Hain, what happens if I put it a little bit different? Well, as long as you didn't put like, this dot all the way over here for L, then you're fine. Okay, so let's take a look at P. 135. Okay, so, well, 11 times 11 is definitely 121, which is less than 135, and 12 times 12 is 144. 135 is definitely closer to 12, so you see my dot closer to 12. Sweet. 170. So 13 times 13 is 169, and 14 times 14 is 196, and 170 is definitely close to 13 times 13. So my dot's going to be real close to 13 right there. And 28 is between 25 and 36. It is definitely kind of in the middle, but closer to 25. And Q is kind of like N. Let's see, it's between 6, because that's 36, and 7, because that's 49. It's kind of in the middle, but closer to 6. Like, yeah, somewhere around here. If you put a little over here, not a big deal. But that's kind of what we're looking for. We want to set the range on our number lines to two numbers between that are a little whose squares are between lower and higher than the square root that we're looking at. And then we're just placing that dot where the square root would be. So that's estimating roots. And now that we've estimated these roots, it kind of becomes interesting to kind of look at it in a different way. So we want to actually order this set of numbers from least to greatest. Now there are all kinds of different numbers, and this is wrapping a bow on this chapter for grade 8 math here in California. And I'm going to rewrite each of these numbers in the same way so I can order them. So the same way is actually for me going to be decimals. So the square root of 30 is about 5.5. So it goes right there. 6 is like just 6. It's already decimal, so I'm gonna put that where that dot goes. 5 and 4/5. 4/5 turns into 8/10, so 5.8. I know where that is, right there, 5.8. That leaves me my last one, 5.36, and the 6 is repeating, not the 3/6. Sorry, guys. That doesn't change where it goes. It's probably going to be a little bit over there. It is. Kaboom. So I've ordered these numbers on a number line to show where they would fall. That's it. Let's take a look at another example. Again, we're ordering these rational numbers. The square root of 5 is going to be about 2.23. Yeah, I used a calculator. It's okay. You can too. 220% is 2.2. So that dot goes here. 2.25 is already a decimal. It is definitely slightly larger than the square root of 5. So that's why it's the black dot is where it is. And 2.2 repeating is in between a little bit more than 220% and a little bit less than 2.23. So I fit that dot in there. Awesome. Ladies and gentlemen, we've ordered rational numbers. Looks like it's time to write your summary. I'm sorry that this video was longer. I guess the biggest thing that we can take a look at is a couple of things I'm going to review real quickly. Make sure that when you're estimating a root, that the numbers that you put on the number line are the numbers whose squares are immediately less and immediately greater than the root that you're estimating. And for ordering rational numbers, make sure that you turn all of the numbers into the same form. Now, using a calculator, the easiest thing to do is just make them all decimals. And that's a review of what we've been doing so far. So if you've been keeping up with me and you are in my class, then go ahead and write your summary. Make sure your table of contents is updated. And if you're not and you're just watching these videos, then hey, keep doing the math.